Hello folks, well it's Boxing Day, so Christmas Day's over. It's the 26th of December. So we're back onto the repairs. No church services until normal Sunday service, so everything's hunky-dory. So we've got a Harrier CBX from an end user whose name begins with C, and he says in his letter fold this in such a way to protect his identity. Hello, Richard, Harrier CBX. Could you repair a tune? I recently bought the radio and it appears that transmit doesn't work, and so it's not been able to fully test that. Right, so I'll tell you what, we're going to have to open it up, aren't we, because it's not going to fix itself. So although there is a similar case to usual, you've got to take all the screws out on these. I noticed a bit of corrosion on the back, so let's hope it's not been highest to be hard and it's got output transistor problems. Let's hope that the coils in the transmitter, the three coils, those coloured coils, the green one and the yellow one and the white one, let's hope that they haven't got broken core, so I don't have to order replacement cores from Knights at Curtin and Lindsay while they still have them. There's lots of let's hopes. So these were £100 radios. They're one of the best performers there is. And they're on a par with the Binatone 5-star. I think you get the bigger speaker with these. No, you don't. I'm lying. They usually perform better than Rotels for some reason, but we've had the exception. That's just gone the wrong way. The lead on it has gone the wrong way, and let's hope it's not had any silly shenanigans. So at first glance I can't see any silly shenanigans. One or two queries with these sets of tools. Where's the blue one in this set? Important one. So this was a Velleman kit, but in recent times we've been having to get these from a arcade game enthusiast repair website in America, and although they're not expensive, like £5, £6, by the time you've added £20 postage into that from coming to America, obviously you need to be buying two at a time. So the green tool in here, not shown, and the blue tool in here are absolutely vital for the Cybernet chassis. The green one especially fits the Amstrad type of Cybernet chassis, and the blue one with this. I've got several of these kits, but that's the one time. So you get a green one, white one, a red one, a blue one, the yellow one, and some extender. So it says Color TV with the American spelling, alignment set. Right, where are we? We're switching this on. You know what we're going to do? We're actually going to connect it up to power. There's supposed to be a power lead stub on here for also some tat on here. Right, so we're powered up now. So we'll have that. Let's see if it works on PA. So plug the speaker mounted on the wall in.
Testing 1, 2.
Good. Well, that's something it does. So I'll transfer that now to the extension speaker socket. And we've got a hiss, so that's good. So that's in high. Yep, that all looks promising. Switch picture in picture on. Meter lamp works. Sockets work. PA works. So going to transmit. And just like he says, there's no transmit. So in the monitor receiver, which today is the Midland Allen 42. Testing 1, 2. No, it's not transmitting at all. So the VCO's wrong. So let's see if it's receiving. So we'll put 2779125 into the signal generator. You can actually hear it receiving as we... This could just be a retuning test. There we go. So I'll tell you what we'll do. We'll go through the synad first. I'll plug the test instruments in. So that's working really nicely. It'd be even better if I showed you as well. So there we are with our 12 dB, and we've got 0.55. Just make sure we're in the right mode. We are. The 10 dB, 0.48. So it already exceeds the manufacturer specification. And for our 20, it's just not quite on the 1. It's 1.3. So we'll test the squelch. Squelch to full. Let's put the attenuator up on the screen. And 3, 10, 30. 100 microvolts, exactly where it should be. Now that might alter as we do the retune and see what the sensitivities of the squelch. .72. The S meter, I've put an S9 equivalent signal of 100 microvolts on, and you know what, that's so close. 140. Good. No transmit. Well, the fact it's not generating the frequency tells me that the VCO's out. Let's hope that's all that's wrong with it. And it doesn't need any actual repairs, just a retune and test. So with the crocodile clip to negative, we'll use that usual strap on there, put the radio to channel 40 and meter to the test point, resistor 4 far end. You can see it's had a prod on there, So we've got 4 volts on receive, and we've got 6.45 on transmit, which is no earthly good, so we'll adjust the red trimmer. Absolutely nothing happening. Now I've had to waggle that round several times. We are taking this to repair level because that's either dirty, faulty or whatever. We'll get a new one installed. The 20 picofarads. Turn the radio off, and now we'll try and remove. So I had to waggle that around about 7 times to get anything happening, and that's no good. I've tried filling them with isopropyl alcohol, sometimes that works, but if it's a customer set, I don't want it to go back and then they've got the same shenanigans. So it's best to cough up and do something that lasts. I've lost my bearings on this. Why is that? Because I've lost my marbles. Should be there. Go in the vertical filing cabinet. So it's got a flat to one side, and that's so your inner and outer is the right way round. So although it's not important as far as the circuit goes, what you don't want to do is to touch it with even with the plastic trimming tool, and it's all over the place reading different. Go over that with isopropyl alcohol as well before sending it back. I'm going to put the bottom on because of its capacitive effect. And we'll go back to where we were. Now that's going to be cooling down, and that's going to affect it. Right, try again. Switch on. And where have I put the mic? In the way. So we've got 6.4 volts. And we'll now adjust the new trimmer capacitor. So I'm looking here on Mr Chippie's bench at the VideoMicroscope. So having changed that part, yeah, I've got lock and it's as stable as anything, that's fine. But we've got intermittent transmit, so this radio got no transmit for 2 reasons.
one, the duff capacitor which we've changed, and secondly there's a dry joint. So you know, you bash the board a bit and it works, and you bash it again, it doesn't work. So we're going to start looking for some dry joints. Immediately I can see this one. That looks pretty ropey to me. All I've got to do is find it. It's that one. I will just say the first thing I did was clean this with isopropyl alcohol, because you're not going to see otherwise. Could be ropey, just where's that? There. You know what? That one doesn't look a million times better either. They don't suffer from dry joints. But you just don't know how they've been stored after they stopped working. So that doesn't look great. In fact, I think we'll just unsolder that. And resolder that. Make sure that's the light shining on it and not anything worse. Wow, that looks a classic, doesn't it? Right in the middle. That one's seen better days. That could be dry joint. Not that I think we're now out, not in the place where the radio is playing up, but I'm going through it anyway while I'm here. That's potentially a classic. Seems to be everywhere except where it should be. That could be. That wants unsoldering. So we're down to the synthesizer chip. That one. Unsolder it. Resolder it. Just do that one. Right, we'll go back to my bench, see if that helps.
Right folks, so we're back on here. We still haven't got transmit, but we've got transmit more than we had transmit. Does that make sense? So, let's go backtracking. So with our test meter, there's the VCO test point. Especially when we connect the negative up. So I did the VCO, well, what channel were I on? On channel 40. There we go, channel 40. So it should be about 4 volts on receive, which we always were. And then the trimmer capacitor wasn't reliable to set. And as you can see, that's now taking us into transmit. That's back to receive. That's transmit. That's receive. Let's go back to channel 1. And we've got 2.3 volts on receive. And we've got 2.3738 on transmit, which is absolutely fine. Just to prove to you all it is transmitting. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So we have got transmit, but it's not coming out to the actual transmitter. So we've got this part working. Whatever the dry joint was, I've now got rid of. And when I go into transmit, the radio is drawing 350 milliamps. So next reason, of course, we could still have a blown output stage. Just don't know how long this lasts working, do we? Just do not know. And then it gets shoved in the box in the garage, and then the rats piss on it, and so on. So with the RF voltmeter, let's see if we can find where it's gone. So our driver transistor is there. Let's see what we've got. Nothing. Little tiny movement. So it's not getting to the driver transistor. So the previous stage, without getting the service manual out, we're looking at around here. Nothing, not a lot, not a lot. Not a lot, nothing, nothing, nothing. I'm either barking up all the wrong trees. So the transistor for that coil when I found the coil, that's there. Should be a transistor about there. No, I think we've got to get the circuit diagram out. I'll tell you what we'll do, we'll just look at the spectrum analyzer. We will. It's there somewhere. So we've set up with the sensor on 2779125. And you can see we have a little tiny bump. If I maximise that with the tuning, now the second coil is having no effect. The first coil's had an effect. The second coil's making no effect. So, have we got a faulty coil? Because if we've got transmit here at coil 2. Let's just look at that again. Transmit. But we've got nothing at coil 3. The plot thickens, as they say. Alright, we'll turn it the other way on and see if we can find anything with the RF voltmeter. So that's 2 faults we've cleared: the faulty capacitor, the dry joints. Just get my bearings. just wonder, you know what? I think I can see a solder bridge between a non-connected pin and chassis. We have transmit. Right, carry on the tune-up now. And it should be pretty stable. I'll turn my little monitor receiver off. Yeah, so now I'm going to reset put this away, get the VCO reset, because I've obviously messed about with that. And it's going to be slightly different with the loading. I've effectively had a short to ground. It's just a whisker. So back to channel 40. Want 4 volts on transmit, so just reset that. And back to receive 4.2, check on channel 1, 2.3 and on transmit 2.3 something. That'll do me nicely. We'll go back to channel 20 and we'll put this meter away as well. We're going to be clearing the decks. And I'm going to break off and have my tea. We'll get through this transmit first. Right, we'll take the spectrum analyzer off, save some electricity. And we'll change to the main meter. And let's have a look. So I'm using the trader service sheet for the Midland 76900 because these circuit diagrams are split. So you've got the transmission and receiver separate. It just makes fault finding easier. A bit more, got some voltage charts on there. Makes it easier for me as a service engineer. So, TX VCO trimmer capacitor, dry joints, short circuit, so RX 4 volts, TX high, RX 4 volts, TX 4 volts. So it's doing 2.7 watts. 2.7 watts on 40, it's doing 2.7, on channel 1 doing 2.8. Normally going to be higher power on the lower channels, even if it's a tiny amount, because it's easy to generate those frequencies. So let's see if we can tune it up. So we peaked this one on the spectrum analyzer, but it may be affected by the malfunction. So let's have a look. Making sure we're still on channel 20. That's the same. That's the same. That's the same. What's good about this is nobody's messed about with it trying to get more watts than it's supposed to do. So as far as it goes, it's factory. I think the biggest snag with this, it's been stored in a pretty damp environment. It's probably for decades, and this is why it's got some dry joints. So I'll get my other trimming tool, which I think came from RS, the white one, if it fits. No, that's not the Cybernet one. Right, we've got the blue one. So we're peaking all these three for absolute maximum. We really need it to be greater than 4.4 watts for us to do a proper tune-up. So we're still at not quite 3. Ooh, it's a bit stiff. That's maximum. Ah, that's got. We've gone beyond 3 now. The radios are supposed to be able to do 4.4 in order to be permanently set for 3.8. But of course the legal limit's 4, so we try and get them to do 4. And 4.1 is I think what we're going to get. So it makes it a bit difficult to tune up, because we're supposed to be taking this one clockwise for 4.4 and this one anti-clockwise for, it says 3.8 but 4, so I'll take it anti-clockwise. So we're now at about 3.99. Let's see what's doing on channel 40. 3.9, channel 1, 3.9. Channel 20. Yes, oh, it's 3.9, 3.95 throughout, to be honest. It's absolutely balanced. So you usually can get that 0.5 more, but not on this one. But at least it transmits. And at least it transmits more than the 2.7 watts it's come in doing. So let's see about low power. And on low power, it's doing what? Should have really checked this. It's not doing anything. It's 0. It might be a dirty preset. Let's hope it's not a faulty preset. I think we've spent enough time on this. There we go, 400 milliwatts. And I haven't got a before current either. Right, so go back to full power. It's 1.16. Right, see whether it's anywhere near on frequency. So should look at 27.79125. It's within. See if we can bring it up a bit. There we are. It's gone up. Spot on. 27.79096, 27.79125. Let's see what the meter says. So when we key it up, it says 5. Want it to read 4. Just the preset for that. About 4.5 on the meter. So it's a bit fast. Deviation. Wallow. Wallow. That says 1.8. We'll just check it with the test set behind me, just in case our Marconi test set is playing up. Sometimes it does, usually it doesn't, but I just like to verify. Just unfortunately I have to change glasses for this one. That's what happens when you get to my age. Wow, yeah, it needs to come up. So the Marconi tester isn't lying. So I want that to centre, and then we'll do the deviation on there. It's probably about there. It's never been messed with, you know. It's probably never worked. Wallow. 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 Okay, so we're now back on the Marconi test set. Wallow, 1, 2, wallow. Well, I did read right, it doesn't now. Wallow. So that's reading slow today. Anyway, it's 2.2 to 2.5. So it was 1.8. Now it's 2.2 to 2.5, which is what we want. See what it sounds like on the monitor receiver. Testing 1, 2, testing 1, 2. Now, where did I put his mic? So it's come with the factory mic. I'm just going to test that. When we do the on the air test, we'll pop this in at the end, but we'll do the test on the standard mic. Wallow. Well, that reads the same. Testing 1, 2, testing 1, 2. So that's a good sign. Right, I'm satisfied we've done transmit, so let's look at receive. Now, it's pretty well how it should have been. I don't think we're going to have any shenanigans. I wanted to get this finished up. It's now 6:30. I don't want to be working. I've been picking at it all day. (27 79125) on the signal generator. Right. I've got an attenuator on the actual speaker so you can't hear it, but you'll see it on the instruments. I'm going to put the speaker back to normal though, because it doesn't work for me. You know, I get comments. People, I can't. This video is unwatchable with all that noise. Well, you know, you wouldn't be able to work in a radio workshop because you've got that noise on for 8 hours a day, and you probably, if you've got several benches, it's going to be slightly off key. And so, yeah, it's just something you have to notch out of your brain and get used to. So that's how life is. So I'm going to put 100 microvolts on the signal generator. Just see where we are with the non-attenuated speaker. Right. Now we'll go to the we will go to the oscilloscope. Check the detector is set correctly. spot on. Didn't need touching. Go to the synod meter. So we'd already got 0.55 microvolts. Just let's see if we can get that little bit more. Will it be another one of those but we can get down to 0.2 something? We've had that on this chassis, on some of these better sets. So we've got that now down to about 4 dB. Wow! I didn't expect that. Massive difference. Why was that coil so far out? That's spot on. Get rid of that lead now. Now we're done with all that shenanigans. You know, I think a lot of people think that's associated with the transmitter, and so it gets twiggled. Right, we're done. Let's see what we've got. We've got 0.25. Wow. So 0.25 microvolts. For 10 dB, 0.21 microvolts, and hopefully it'll do 20, yeah, 0.75. Now then, let's see what that meter says. So, at the moment, it says S7 for an S9 input. Just make sure RF gain's at full. RF gain's not at full. We've got what? 67 microvolts for that. See, it's changed now. We've done the. I've clonked the RF gain. It's not that it. I've not been doing everything with that wrong. It's picking this set up. Yes, so I'll put 100 microvolts on, and let's get that adjusted. Totally different now. I've retuned that coil. See where the squelch is now. It's now 30 microvolts, it needs resetting. That's it. Let's reset. So it doesn't look like there's been any change, but in fact I've had to reset it for the reasons you've just seen. Let's see where its sensitivity is now. Signal generator to standby, parked at 0.3 of a microvolt. Not 0.72. Yeah, it's exactly where it was before. Let's check that tone control. Yep. Like. Wow. Well, it's turned out a nice set. Just going to recheck transmit. So just go back to the main meter, because the transmitter will now have been able to cool down. Yeah, it's doing 3.95, so that's fine. Slumming sight more than most new sets will do. get that speaker unplugged. I'll tell you what I'll do, I'll put it on the aerial while we put the screws in. Then you never know, it's 6:30, we might hear somebody on. Let's put it on 19. So once again, I didn't think we were going to get anything better out of receive, but we did. These people will be at Nottingham, but bit of a burner brigade at Nottingham, so don't expect them to be on 4 watt. I think it's a disgraceful loophole that shops are allowed to sell illegal linear amplifiers, burners, even though, of course, they're going to be used illegally. And when I've inquired of people selling those, oh well, you know, there's a good profit on it, and well, if we don't sell them, somebody else will sell them. Well, let somebody else sell them, and don't be aiding and abetting illegal activity, you know. But oh no, they want that extra 10 quid profit, don't they? So, really frustrating, because it just so spoil it for others. They don't realise it. Oh, they probably just don't care. Every time I move this radio, I knock these knobs. That doesn't want to go in. Perhaps that's one that didn't come out. One on a Roger.
The key to getting there's 8 P points or something, and it gives you these on the thing, on the gain, and the better you get and the more efficient and on time, you'll get these more points, like driver points we'll call them, I suppose.
Well, we actually heard somebody on it. That's incredible. Right, so that's the Harrier CBX, all back in the land of the living. That's worked out all right, and it wasn't too scary. We'll just put a price on that. Right, thanks for watching. Might be doing our Mr Benefactor's repair, the final one of his 3 77805D.